Combination and permutation. I'm Anna Jubarabita here. Welcome to my video. Taking a look at combination. A combination is an arrangement where order does not matter. And does not should sound kind of familiar actually. Very similar to our definition permutation. Means order does matter. Deeper into the relation between the two of these later. Back to combination, remember their order does not matter. Usually they show us this equation, a while back, have been kind of frightening for us. Let's take a look at from the abstract first. Question, how many different sampler pliers can we make? And we've got 5 different options, therefore appetizers, and we're gonna choose 2 of them. It's a 5C2. Let's not worry about those numbers right now. Just focus on thinking. Just from the cluster of the conceptual standpoint. I could have wings with chips and dip. I could have wings and nachos. I could have wings with fries. I could have wings with potato skins. So that was 4 different combinations. You can try those out using abbreviation. Actually do the same for the other. Comes on the menu. I could have chips and wings. I could have chips and nachos. I could have chips and fries. And I could have chips and potato skins. Same is true for the rest of the items. Are there any difference between wings with chips and dip or chips and dip with wings? Any difference between chips and dip and potato skin or potato skin and chips and dip? Arrangements, the order does not matter. It doesn't matter which I ordered first, which go first on the plate. I have the same meal. Actually go through there and remove the duplicate item first. Wings and chip and dip. Let's see if the item comes again. And sure enough, it does right below. Chips with wings, the same thing for wings and nachos. Find all the matching pairs and there's only one, nachos and wings and fries, fries and wings and potatoes, potatoes and wings. You see that make kind of interesting pattern here. You notice that pattern continues as we go through different options. So we are literally knocking out a pair. See, we got all finished. You can see we're left with 10 different menu choices. When they ask how many different platters can we make, so that the 10 or 5C2. Another example, here we have fresh pizza. You want to know how many different 2-topping pizza can we make? There are 7 different toppings. We're gonna select 2 of them, so that's 7C2. Not gonna worry about the numbers right now. Here are the different types of toppings. Different kind of combination that can be made are listed here. Again, we cancel out the doubles. Notice that we'll lose half of our options. And when we try to answer the question, how many different 2-toppings pizza can we make? We know there is 7C2 or 21. Go ahead and take a look at the math. Know that NCR means the number of combinations that can be made from n items when you're selecting R. So in that case of 7C2, that's the number of combinations that can be made from 7 items selecting 2. When we think about NCR, here's the equation they gave us. In factorial over factorial times a quantity and minus R factorial. Again, might have been frightening. You know, all we have to do is plug. We had something like 7C2. We could go ahead and plug in 7 and 2. Then we could solve it out. Let's start by doing the factorization on top. Okay, writing out the expansion. Let's deal with the parentheses on the bottom. 7 minus 2 is 5. Deal with this factorial, 5 factorial, and 2 factorial. Notice once we expanded out those factorials, then we have sort of repeat here. Same items on the top and bottom. We can do is factor those out into their own. Remember the rules of multiplication with fraction. Same numbers over each other, that's 1 over 1, or simple 1. We're just left with just front two parts of our formula. Let's go ahead and solve 7 times 6 over 2 times 1, that's 42 over 2, or 21. You can also look at the math from the earlier problem. We had 5 different options for our appetizers. The 2 that we're gonna select for our dish. We can go ahead and plug those in. Go ahead and substitute. The same deal happens here. 3 times 2 times 1 over 3 times 2 times 1. Remove that back half and leaves us with 5 times 4 over 2 times 1 is 20 over 2 or 10. When we're looking at the general rule.NCR, we notice that the formula looks very similar to formula for permutation. The difference between them is the art factorial in the denominator. If you factor out the art of factorial into separate, we can actually replace the in factorial part of the equation there with NPR. Multiply by 1 over art factorial, and that gives us NPR over our factorial. The combination is really just a permutation. Number of objects selected as a factorial. And if you remember our shortcut for solving permutation starting at the end, count down our numbers, multiply. We can actually use that exact same rule. We are solving combination using this equation. Go ahead and start it in. Count down our numbers, so 3, and then multiply them together. I can do the same. Go and start with art. Count down our numbers, multiply. Go ahead and finish up the math there. Reduce the fraction, gives us answer of 84. Different combination, we're doing 9C3. And if you notice, the 9P3 is 504 and 9C3 is 84. Those numbers demonstrate that a combination is a permutation with doubles taken out. Just real quickly to do 7C4, all we have to do is 7 count down 4, multiply them together, then do 4, count down, multiply them together, and solve. Okay, proceed to the last one. Combination and arrangement where order does not matter, permutation and arrangement where order matters. Combination are good for groups, teams, piles, etc. It doesn't matter. Permutation are good for order, list, computation, resolve, etc. Are good for order list. Here's the example. Yvette is throwing a blowout sweet 16 party. She has a 14 VIP girls, but only 5 can fit with her in the limo. How many different entourage could Yvette arrive with? Combination 14C5 equals 2002, and that's the result.